Hello student, we continue chapter 5 JEE. 20th sum. If f from R to R, fx equal to minimum x plus 1 mod x plus 1, then which of the following be true? In 2007 this question be asked. A is given that fx is differentiable for every x. B is given that fx is greater or equal to 1. C is fx is not differentiable at x equal to 0, and D is fx is not differentiable at x equal to 1. So here this function is given. Here fx equal to minimum of x plus 1 and mod x plus 1. So here mod is given, therefore we take two different type of cases. First, x is greater or equal to 0, then minimum of x plus 1 and x plus 1. Second is minimum of x plus 1 and minus x plus 1 where x is less than 0. So fx equal to minimum of x plus 1 for x is greater or equal to 0 and minimum of x plus 1 and x is less than 0. So in both cases we get this same answer, that fx equal to or this is not we directly put this fx is as it is because of this is our answer. So x plus 1 and x plus 1. So we can say that fx equal to x plus 1. Therefore fx equal to x plus 1, and we know that this is polynomial function and this is polynomial function as well as f dash x is equal to 1. So we can say that it is differentiable for all x belongs to R, because we know that polynomial functions are differentiable. So we can say that here f is differentiable for every x belongs to R. So this is quite different type of sum is that, but here first you take two different type of case and then you go for the sum, then it is quite easy. In 2007 this type of question can be asked. Okay, we go for the next one. Next question, 21. The function f from r minus 0 to r given by fx equal to 1 upon x minus 2 upon e raised to 2x minus 1 can be made continuous at x equal to 0 by defining f0 as dash. 2007 question is there and A, B, C, D options are there. So we just find. Okay, first of all we want to define f at x equal to 0 such that f be continuous. Here f be continuous at x equal to 0. Therefore limit x tends to 0, fx means 1 upon x minus 2 upon e raised to 2x minus 1 is equal to f0 for the continuity. Now we just simplify it, and first of all we take the LCM. Limit x tends to 0, e raised to 2x minus 1 minus 2x upon x into e raised to 2x minus 1. It is f0. Now when you put the limit, then this is 0 upon 0 form. This is 0 upon 0 form. So when 0 upon 0 form is given, then we apply L'Hospital rule. So here we apply L'Hospital rule for numerator and denominator. So 2 e raised to 2x minus 2 upon multiplicative law. First 2 e raised to 2x plus e raised to 2x minus 1 is equal to f0. Now limit x tends to 0, 2 e raised to 2x minus 2 upon 2x e raised to 2x plus e raised to 2x minus 1. It is f0. Now again we put the limit, then again we get 0 upon 0 form. So this is also 0 upon 0 form, and here we apply LH rule. right? So remember this thing very carefully. Now again we get the 0 upon 0 form, so we again use L'Hospital rule. So we have limit x tends to 0, 4 e raised to 2x upon first here 2 in bracket x 2 e raised to 2x plus e raised to 2x plus 2 e raised to 2x is equal to f0. Here we apply LH rule. Therefore, limit x tends to 0, 4 e raised to 2x upon 2 means 4x e raised to 2x plus 2 e raised to 2x plus 2 e raised to 2x equal to f0. So when we simplify it, then we have limit x tends to 0, 4 e raised to 2x upon 4x e raised to 2x plus 4 e raised to 2x equal to f0. Now here we just simplify it and now we find the answer, or we just put the value of the function, then we have so therefore here we put, now we put the limit, then we have 4 e raised to 0 upon 4 into 0 plus 4 e raised to 0 equal to f0. So when you simplify, 4 by 4 is there, it is 1. So we can say that for this function is continuous, f0 is equal to 1 is the answer. So B is our answer. Okay, now we go for the next one. Okay, next sum. Fx equal to x minus 1 sine 1 upon x minus 1, x is not equal to 1 and it is 0 for x equal to 1. Then which is true? In 2008 this question is asked. Here f is not differentiable at x equal to 0 and x equal to 1, f is differentiable at x equal to 0 and 1, f is differentiable at x equal to 0 but not differentiable at x equal to 1, and D is the reverse, f is differentiable at x equal to 1 but not differentiable at x equal to 0. Okay, now here we know that fx equal to x sine 1 upon x for x equal to 0, x not equal to 0 and 0 for x equal to 0 is continuous at x equal to 0 but not differentiable at x equal to 0. So we use this result here. Here only x minus 1 is there. So fx equal to x minus 1, 1 upon sine 1 upon x minus 1 where x is not equal to 1 and 0 for x equal to 1 is continuous at x equal to 1 but not differentiable at x equal to 1. Okay, so this way this function is not continuous at x equal to 1, right? And it is not differentiable, it is continuous at x equal to 1 but not differentiable at x equal to 1. So here if we see that the answer is C, so f is differentiable at x equal to 0 but not differentiable at x equal to 1. So our answer is C. Okay, so some reference is also helpful for solving this type of sum. So remember this thing very carefully, that all the sums are different with different logic and with different method. So use this different method for the JEE question. Okay, we go for the next one. Okay, next sum 23. In 23 sum, if y is an implicit function of x and is defined as x raised to 2x minus 2x raised to x cot y, minus 1 equal to 0, then y dash 1 equal to dash. In 2009, this question is asked, answer are 1, log 2, minus log 2 and minus 1. Okay, so we start this sum here. X raised to 2x minus 2x raised to x cot y minus 1 equal to 0. Let fx equal to x raised to x, then f dash x equal to x raised to x 1 plus log x. Okay, now we put gxy is equal to fx square minus 2fx into cot y minus 1. Right? This is a function gxy. Now we want to find the derivative of this gxy. So dy upon dx of this function is equal to d upon dx of gxy as y is constant and upon d upon dx of gxy as x is constant. Right? So here when y is constant and we derivate this function, then 2fx into f dash x minus 2f dash x cot y upon, as this is constant and this becomes 0, this becomes 0, minus 2fx into cos x square y. Okay, or this becomes plus. Now 2 is removed, so our answer is fx into f dash x minus f dash x cot y upon fx into cos x square y. Okay, so this is our first answer, but here cos x square is equal to what? 1 plus cot square. So we just put it fx into f dash x minus f dash x cot y upon fx into 1 plus cot square y. Now we want to define, or we want to find y dash 1. So for this y dash 1, first of all, if here this is our first result, if x equal to 0, if x equal to 1, then this equation x raised to 2x minus 2x raised to x cot y minus 1 equal to 0 gets 1 means 1 minus 2 cot y minus 1 equal to 0 means cot y is equal to 0. If cot y is equal to 0, then we can say that f dash 1 equal to 1, f dash 1 equal to 1 and f1 equal to 0. f1 equal to, sorry, it is 1. This is our second result. Okay, so from these two results, now just you put here the result, then you get your answer. F dash 1 equal to 1 and f1 is equal to 1. Okay, so now we obtain these two results. Now we just put this from 1. So dy upon dx or y dash 1 is equal to f1 into f dash 1 minus f dash 1 into cot y is 0 upon fx into 1 plus 0. So this way f1 is 1 minus means 1 upon 1, it is 1. So our final answer is A, it is 1, but here one thing is there. Okay. Minus. Okay, here one thing is remaining, that here you put negative sign. Okay, this is forgettable. So we just put here this sign. So our answer is minus. Because when we take dy upon dx, then here you take negative sign and then you put the process. Okay. So this way we obtain, our answer is not 1 but minus 1. D is our answer. D. This D is our answer. Okay. Okay, next sum. If 24th, if f from minus 1 to 1 to r is differentiable where f0 is minus 1 and f dash 0 is 1, gx equal to f bracket 2 fx plus 2 whole square, then g dash 0 is equal to dash. This question is also asked in 2010. So remember this thing very carefully. Now we just derivate this function. Here gx is equal to f 2fx plus 2 whole square. Okay, so here g dash x is equal to 2f 2fx plus 2, then applying chain rule, 2f dash x. Just a minute. This is for this and this is f dash 2fx plus 2 and into this result d upon dx of this means 2f dash x is there. Okay, so whole limit is 2fx plus 2 into f dash 2fx plus 2 into 2f dash x. Now we put g dash 0. So g dash 0, it is 2f0 plus 2 into f dash 2f0 plus 2 into 2f dash 0. Now all the values are there. f0 and f dash 0 both are there. So 2f0 is 1, so 2 plus 2 into f0 is minus 1, so minus 2 plus 2 f dash, now here minus 2 plus 2 into 2 f dash 0 is 1. So we have 2 f0 into f dash 0 into 2. This is 4. F dash 0 is minus 1 and f0 is 1. So our ultimate answer is minus 4. Okay, so this answer is minus 4 according to the given data and it is A. So this way we complete our 24th sum. Okay, then we go for the next one. Okay, 25th sum. If fx equal to sin p plus 1x plus sin x upon x, x less than 0, q x equal to 0, root x plus x square minus root x upon x raised to 3 by 2 x is greater than 0, is continuous for all x belongs to R, then p and q is equal to dash. And this is 2011's question. So first of all, here f is continuous at x equal to 0. Therefore, limit x tends to 0 plus fx equal to f0. It means limit x tends to 0 plus root x plus x square minus root x upon x raised to 3 by 2 is equal to q. Now taking this root x common and cancel, we get limit x tends to 0 plus root 1 plus x minus 1 upon x, and we multiply and divide with conjugate sort. Root 1 plus x plus 1, not minus but plus. So here in numerator, limit x tends to 0 plus 1 plus x minus 1 upon x into 1 upon root 1 plus x plus 1 equal to q. This 1 is removed and then 1 x are also removed. So limit x tends to 0 plus 1 upon root 1 plus x plus 1 equal to q, and it is, when we put here 0, then 1 by 2 is the answer of q. This is our first answer. Now we talk about left hand limit of the function, and limit extends to 0 minus sin p plus 1x upon x plus sin x upon x, it is also q. Here we multiply and divide with p plus 1. Then when we put limit, this become 1. So 1 into p plus 1 plus 1 equal to q. But q is also given 1 by 2. Therefore p is equal to 1 by 2 minus 2, it is minus 3 by 2. So therefore p is minus 3 by 2 and q is 1 by 2, which is our answer. Okay, and the answer is B. B for Bombay. Next question. So sorry, this is quite okay. So this way we find our answer, and now we go for the next one. Okay, 26. Defined fx as a product of two real function f1x equal to x, x belongs to R, and f2x equal to sin 1 upon x, x is not equal to 0, and 0 at x equal to 0. As fx equal to f1x into f2x, where x is not equal to 0 and 0 if x equal to 0. 2011's question is there, and here two statements are given. First statement is the fx is continuous on R. First. Second is statement is f1x and f2x are continuous on R. And we want to A, B, C, D. There are 4 type of options are there. First option is statement 1 is true, statement 2 is true. 2 is correct explanation of 1. Statement 1 in B, statement 1 is true, statement 2 is true, but 2 is not a correct explanation of 1. Statement 1 is true, statement 2 is false. Statement 1 and 1 is false, statement 2 is true. So this type of 4 options are given. Now we start it. Okay, according to the given statement, we know that fx equal to x into sin 1 upon x. X is not equal to 0 and 0, x equal to 0 is continuous on R, right? This is, we know that. Therefore, we can say that statement 1 is true. Statement 1 is true. First. Now, next thing is this one. Here, f1 x is equal to x, x belongs to R is continuous on R. But when we talk about f2x equal to 1 upon x, then it is not exist. Or we can say that here limit x tends to 0 plus sin 1 upon x does not exist. Right? If limit does not exist, it means what? f2x is not continuous. f2x is discontinuous on x belongs to R or on x equal to 0. So therefore, our first statement is true, but second is false. So our answer is statement 1 is true and statement 2 is false. So this is our answer. So be careful and remember this thing very carefully. Some new concepts are there, so remember this thing very carefully. Now we go for the next one. Okay, next 27. If f is differentiable at x equal to a, then limit x tends to a, x square fa minus a square fx upon x minus a is equal to dash. It is 2011's question is there. A, B, C, D options are given. Now here first of all, here f is differentiable at x equal to a. Therefore, limit x tends to a, x square fa minus a square fx upon x minus a is equal to fa. And we just here simplify. This is, if you put a x equal to a, then this is 0 upon 0 form. So we directly apply L'Hospital rule. So that is equal to limit x tends to a 2x into fa minus a square f dash x upon 1. Okay, according to LH rule. Okay, now LH rule is there. Now this is not 0 upon 0 form, so directly we put x equal to a. So 2a fa minus a square f dash a. This is our answer. So according to L'Hospital rule, this sum is very easy. But when you do the original method, then it is quite lengthy. So this is time saving technique. So be careful, be remember. 2a fa minus a square f dash a. So C is the answer. Okay. So this way we clear all the 25 sum, 27 sum. Now we go for the next in next.